Welcome to Zaption Tour 6.2, Solving Systems Using Substitution. Here is the essential understanding. It says this: when a system has at least one equation that can be solved quickly for a variable, the system can be solved efficiently using substitution. I want to highlight the word quickly here. That's the whole key to this, because if you can't do it quickly, then you might want to try a different scenario, which we'll talk about in the next section. But for right now, this is where we're going. Box number 1 is an example. It says to do the following: solve the system using substitution. So let me show you what we mean by substitution. I have a system over here. All right, my first equation says y is equal to 3x. My second equation says that x plus a y is equal to negative 32. Well, the whole point of substitution is to say that if I know that every y is worth a 3x, then I could take 3x and substitute it into the second equation. So I would have a new equation that would read like this. I'd bring this up here and say, all right, x plus, instead of writing y, I would write what y is equal to as given in the first equation. So I would say x plus 3x is now equal to negative 32. Well, now you'll notice that I only have one equation that only has x's in it. I can add these together because they're like terms. So that gives me 4x is equal to negative 32. Solving for x, I would divide by 4. I would divide by 4. And I would get that x would be equal to 32 divided by 4 is negative 8. Negative 32 divided by 4 is negative 8. Now that's only half of the solution, because remember, a solution to a system is an ordered pair x comma y. So I need this, and right now I only have half of it. So how do you suppose I get the other half? Well, I simply substitute it back into anywhere that I want and figure out what y is. I'm going to choose to go ahead and do it in the first equation. So substituting in for that, I would see that y is equal to 3x, but I already know what x is, so y is equal to 3 times negative 8. So therefore, y is equal to negative 24. So the solution to the system would be the following. It would be negative 8 comma negative 24. And that is how you solve a system using substitution. Box number 2 is another example. It says solve the system using substitution. Okay, so here's my system. In my first equation, I see that y is equal to 2x plus 7. In my second equation, I see that y is equal to x minus 1. Well, notice that in both equations, y is solved for. So therefore, if I know that y is equal to 2x plus 7, I could substitute it into the second equation and have a new equation that would read this. Instead of writing y, I would write down 2x plus 7 is equal to, on the other side, x minus 1. So I substituted the value of 2x plus 7 in for y. Now I would just solve normally. So I would subtract x. I would subtract x on both sides. 2x minus x gives me just x plus 7 is equal to negative 1. I would subtract 7 from both sides, and I would get that x is equal to negative 8 again, oddly enough. So remember, that's only half of my solution, right? My solution is an ordered pair. So far I have negative 8, comma, I need the y value out of this. I don't know what it is yet, so I'm going to take the negative 8 and substitute it back into either one. It doesn't matter. I can put it here for x, or I can put it here for x. It doesn't matter. I'm going to go ahead and choose the second equation because it looks a little easier to me. So I would say y is equal to x minus 1. So now I know the value of x is negative 8, so negative 8 minus 1. So therefore y is equal to negative 9. So the solution to my system would be negative 8 comma negative 9. Box number 3 is a you try. I want you to try this on your own. Solve the system using substitution. Look back to box number 1 in your notes if you need help. Hopefully you got the right answer. If you did not, here's the solution. I noticed that y is equal to 3x, so I take that information and I substitute it into the second equation. So I get x plus 3x equals 8. Then I see that x plus 3x is 4x, so 4x equals 8. Then divide by 4, and I get that x is equal to 2. Take the value of x equal to 2, substitute it right back in for any x that you want, and I showed you the work right over here. So I said y was equal to 3x, so I substituted x for a value of 2, and I got y was equal to 6. So the solution should have been 2, 6. Box number 4 is a more complicated example of using substitution. Notice the directions say how to solve for a variable and then use substitution. So let's take a look at our first equation. I have 3y and I have a 4x and then I have 14. So I would have to isolate the x or the y and then divide by either the 3 or the 4 to get an x or y by itself. But if you'll notice, in the second equation, I have a single y variable sitting right there. So it's a lot easier to solve for that variable in the second equation than in the top equation. So that's what I'm going to do first. So I'm going to take this equation here, and I'm going to solve for y. So I would get this. Y is equal to positive 2x minus 3, just by adding 2x to both sides. Now what I'm going to do is I'm going to take every y that I see in the first equation and replace it with a 2x minus 3. So I'm going to take this information and I'm going to plug it right there for y. So here's what I would get. I would get 3 times a value of 2x minus 3, because I've now substituted 2x minus 3 for y, plus 4x would be equal to 14. Now I'm going to distribute. So 3 times 2x gives me 6x. 3 times a negative 3 gives me a minus 9, plus 4x is equal to 14. I'm going to continue to solve for x. So I'm going to get 10x minus 9 is equal to 14. I'm going to add 9 to both sides. All right? And I'm going to see that 10x is now equal to 23. And then I would divide by 10, of course, on both sides. And I would see that x is equal to 2.3. And that's okay, you guys. It's okay to get a decimal of 2.3. Don't freak out about that. But again, we're still not done, right? Because we have to take this information and we have to substitute it back in. Now remember, you can use any equation that you want. So I'm going to plug it right there. All right? So I'm going to finish the problem off over here. So I'm going to have negative 2 times x plus y is equal to negative 3. So I'm going to have negative 2 times the value of x, which is 2.3, plus y equals negative 3. So negative 2 times 2.3 is negative 4.6, plus y equals 3. And then just simply add 4.6 to both sides. And you get this. You get y is now equal to 7.6. Oh, this is a negative 3, excuse me. So you get 1.6. So therefore, the solution to this would be 2.3, 1.6. That was a hard problem. Box number 5 is another example of one of these more challenging problems. So let me show you how it's done. I'm noticing that my x value in my second equation is all by itself. So I'm going to go ahead and solve that equation for x. So I would get this. X is equal to negative 3y minus 7. So now I'm going to replace every x that I see in the first equation with a negative 3y minus 7. So I'm going to go ahead and put it right there. Okay, so let's go ahead and do that. I'll switch colors for you so you can see. So I'm going to have 6y plus 5. Now instead of writing x, I'm going to write down negative 3y minus 7. And then on the other side equals 8. So I have substituted the value of negative 3y minus 7 in for x. And now I'm going to solve for y. Okay, so 6y is equal to 5 times negative 3y. Or, sorry, this is a plus sign, pardon me. 5 times negative 3y is negative 15y. 5 times a negative 7 is a negative 35. On the other side, I get a value of 8. Okay, so if I take, I'm going to now combine these two. So I'm going to get negative 9y minus 35 is equal to 8. All right, I'm going to add 35 to both sides. I'm going to add 35 to both sides. So I get negative 9y is now equal positive 43. And then I'm going to divide both sides by negative 9, divide both sides by negative 9. So I get y is equal to negative 43 divided by 9. You can leave it just like that. You can leave it as a fraction. That's okay. Or if you want, you can plug that into your calculator and get the decimal equivalent. So I brought my calculator up. If you want, you can turn it into a decimal. So if I take 43 and then I divide it by 9, you can get 4.78 if we round up. Okay, or approximately 4.78. That's okay too. Okay, we're still not done because we have to now solve for x. So take your value for y and substitute it anywhere you want. I'm going to go ahead and put it right there. Okay, so I'm going to get x is equal to negative 3 times 4.78 and then minus 7. So x is equal to, if you don't know what that is, that's okay. You can use your calculator for that. And you just get negative 3 times 4.78. You're allowed to do that. That's totally fine. And then you want to subtract 7 from that value. So we get negative 21.34. Negative 21.34. Again, that's okay. You can get these decimal answers. So therefore, our final answer would be negative 21.34, comma, 4.78. Okay, so I found my mistake. This should be negative 4.78, which makes this negative 4.78, which makes my x value 7.33. Okay, box number 6 is all about a system that has infinitely many solutions versus a system that has no solutions. So in the first example on the left, I have an infinitely many solutions example. So notice that x is equal to negative 2y plus 4. So I'm going to take all this information and substitute it into x into my second equation. So I would have this, 3.5 times the value of negative 2y plus 4 plus 7y is equal to 14. Now distribute. 3.5 times negative 2 is negative 7y. 3.5 times 4 is a positive 14. Plus 7y equals 14. So hopefully you can see what's happening here. Negative 7y cancels with positive 7y, and I get that 14 is equal to 14. Well, that's a true statement, isn't it? And if that's a true statement, that implies that I would have infinitely many solutions to this system here, which means that each equation is just a replica of the other. Now let's compare that to this other one over here with no solutions. Notice that y is equal to 3x minus 11. So I'm going to go ahead and substitute that into my second equation. So 3x minus 11 minus 3x is equal to negative 13. Well, you can see that 3x minus 3x cancels out, leaving me with negative 11 is equal to negative 13. Well, that's totally false. And if we get a false statement, that would imply that the system has no solution. So that means that this original system has no solution. Their lines would never cross.